Hello, I am back with another video. This one is actually a request from my previous one. The request is concerning implementing the teleportation ability as described in Unreal Engine's sort of documentation or guide on working with the character movement component. I forgot to link it actually in my previous video because I do remember at some point looking at it, but I completely forgot that it existed. But it does make a good job in providing an overview of how the character movement component generally works. And it also provides like 4 ways of implementing the teleportation ability and why most of them won't work because of networking consideration primarily. First, I'm going to demonstrate how the ability works. So I'm still using the previous project, the jetpacking tutorial, with slight modifications that I played around for a bit. So by pressing a key, I start this, ignore the weird line that's for some reason dancing around me. I'm not sure what it is. It seems to be actually a glitch of the engine. Because that is obviously, as you might expect, the line trace of where I am looking at with my camera. So I'm tracing a line somewhere into the world and I'm placing this fire particle system where it lands. And when I release the button, I get teleported there. If it isn't something like a wall, I can even get teleported all the way up there onto those cylinders that I use as a visual guide for when I'm gliding. So yeah, that's it. Simple teleportability. Nothing great, nothing especially problematic. Well, I say especially problematic, but let's take a look at the code. So following the template from my previous video, we're just going to create some state variables. Those variables are going to be B1s to teleport, which is also something that is advised to be created in the Unreal Engine's guide. They specifically mention the use of compressed flags. I do not use them because I don't see necessarily the need to do that, but also because I am also needing the teleport destination state variable. So, you cannot fit that into a flag. And that's a vector. That's a location in the world to which I wish to teleport. Let's take a look at how we are setting this. So over here, we're creating, again, this is formulaic, this is mechanic, this is just copying my previous code and changing the names. I'm going to create a method called setTeleport. We're taking in those 2 values, once to teleport and destination. If either of those values is different from what is currently cached, then we are going to actually set the values in this inner sort of execution method. So exec set teleport has the same signature, does the actual work. And then while networking, again, doing the same thing. If I am not a server and I am locally controlled, then I'm going to notify the server to execute this on his side as well. And if I actually am a server and I'm not locally controlled, then I'm going to notify the client that owns this pawn. I'm going to notify him to set this on his end. So I think that's that, and I'm just going to take a look at the implementations of the RPCs. These are the things that actually execute, and it's just a redirection into the exec function. Both client and server RPC does the same thing. The validation, I do not do any validation for now. That's just returning true. But this is something where sanity checks should be applied, obviously. Furthermore, the state variables have been created in this fSaved move character. So I have created a saved wants to teleport and saved teleport destination. I changed or amended the prep move for function so that it internally executes the set teleport with these 2 parameters that are saved. This is, again, the function that sets up the character movement component into the required state so that it is able to replay a move after server adjusts client's position. And of course, on the other side of things, this is when the move is populated with the saved variables. So here, saved wants to teleport equals to B, wants to teleport from the character movement component, as well as the saved teleport destination. One more is amending the can combine with function so that when the wants to teleport is not equal in between the 2 moves, then make it impossible to combine the 2 moves and discard one of them. Same goes when the saved teleport destination is not equal, because both of these should be checked against to not be combined. Now, how do I utilize those two state variables? So on movement updated, which again is a function that gets called after the whatever movement mode there is processed, I'm going to check if I do want to teleport. I'm going to check if I can teleport, which is again can and want. The condition is I have to be walking, so I cannot teleport while am I falling or jetpacking or gliding, only while I'm walking. This is arbitrary. This is just something I decided. You can do it any other way you wish. And when those two are met, I'm going to call the actual teleportation. I leave this in here because this is a toggle. This is a key press basically. This is not something that you should hold, or rather you do actually hold it, but when the state doesn't actually alter whether you press or release. There's only one state change related to the input. So only when you release the button, then the teleport is set. Okay, for example, something like jetpacking, when you press, you turn the state on, and you release and you turn the state off. Same goes for sprinting. You hold shift or you hold the sprint key, you sprint, you let go of the sprint key, you stop sprinting. For gliding, it is doing the same thing twice, is entering and leaving the state. This is a third version where just pressing the key sets the state. It doesn't unset it. So this is different from the three other sort of things we played around with. But you might notice I'm not actually setting any custom movement mode. This is not necessary to implement a custom movement mode just for this. This is an ability, as it is referred to in the Unreal Engine guide. So let's see what actually happens in this teleport function that gets executed when all the conditions are met. So I'm just going to move the updated component. This is, for some reason, this method requires you to pass in delta. So I'm passing delta from the current location to the target location. I'm not changing the rotation. I'm keeping the rotation as is. That's something you might want to change depending on your use case. I'm specifically setting that do not sweep. If you turn sweep on, then it's going to check for collision along the way. So this is specifically a teleport, so it's false. We are not going to do that. The rest is obviously the output of the collision check, which shouldn't be actually done. And for some reason, I saw somewhere in the documentation that this isn't used at any point. But still, I just used this enum value because its description is that teleports physics body so that velocity remains the same. So I'll just pick that. Again, I think I saw documentation somewhere that refers to this not being used. So then when the pawn is locally controlled, I'm going to play a sound. I think that was something you were able to hear. Let me just check. Oh, yes. So this is obviously the Enderman teleports out from Minecraft, which is, I believe, is highly copyrighted. So you can potentially get this video struck down for that if you were to be so inclined. So I'm going to play a sound at the location that I'm teleporting onto, and then I'm going to do this, which is an interesting change over the things that we have been doing, or rather I have been doing in the previous video. And then I set the actual values. Now, notice I do not call the wrapper method. I do not call set teleport. I'm calling directly exec set teleport. I'm directly setting the values. I'm resetting the flags. Now, the reason I have to do this, specifically this, and not the wrapper method, because there's a funny thing that happens. So on the client, when this gets called, the flags are set, everything is dandy. Then the RPC call is made. So a request is sent to the server to do this, to do the same, to execute the implementation. Then the client goes on its merry way, processes movement, gets to here, processes the teleport, okay, starts teleporting, executes the teleport, gets to here, and if this was just set teleport, it then sends the RPC again, except this time with the flag being unset, the flag being set to false, because that's the parameter here. When it comes to server executing this, server receives both of these RPC calls at once, and because this is a reliable RPC call, they get set in the same order. So meaning first is set the true call, or the call where the flag is set to true, and then he receives the call when it's set to false. So when it comes to him, the server, executing the same code, he gets to this point and the flag is already set to false. So the teleport doesn't actually happen on his end. And then he notices that his position, the position of the client is off because the client did execute the code and he did teleport. So he tells him to correct his function and teleport, yoinks him back, rubber bands him back. Let's actually, while I'm talking about it, I can do demonstrate that, but for safety purposes, let's turn off the blueprint. Because there's a glitch that happens that when you rebuild your C++ project, then any cast nodes in your blueprints that cast to the components built in the C++ get corrupted and you have to remake them. So this won't actually work with just one client because this will only work when it's the client that's doing that's teleporting. Server teleports fine, like this. Oops, inside the cube. But the client, yoink, gets pulled back because of the reason I laid out. Basically, the client is way too fast and sends the server an update that contains the flag set to false, and the server then yoinks him back. So that's why you have to sort of break the synchronization that you would normally do in these other methods, and you have to just let the process handle unsetting the flag as a result of completing the teleport locally for both the server and the client. So yeah, I'm gonna have to do this, and when I do this, it's all fine. It works. It just works. So again, let's see how the server teleports fine, and the client this time teleports also fine. Yay. So now going back to this multicast thing that I do here, the playing of the sound. So the way I play the sound, if it's locally controlled, then just play the sound. And the way multicast RPCs work is that only the server calls them. Only the server can execute multicast RPC calls. So this is a request the server sends to himself to execute an RPC, and a multicast RPC implementation, which is over here, executes both on the server and on every single client that is connected. Server goes from here into here, but because of this condition, so only play this sound when the pawn this is related to is not locally controlled. That's why it won't execute twice on the server. But every single client that receives this multicast executes this and plays the appropriate sound. The sound, the location that is played is obviously the destination of some other client that teleported. When I start up 3 instances, so here I have the server, here I have the 2 clients. And you can see the sound playing twice there, because it did actually play on both machines and both instances of the clients. The way it looks now, every client has 3 proxies around him, and as you can see, I put a little overhead text there that says a proxy. Now, interesting thing about proxies, they do not have a controller. So there's a code that turns them black, specifically if their controller is not valid. And interestingly enough, it would appear that the simulation is not running for them. Like the movement code that you implement is not really running for these guys. So if you have something like the custom movement mode and the gliding stuff and jetpacking stuff, none of that really executes on these proxies, on these black guys. It only executes on the server over there and on the client locally, specifically on the character that is locally controlled. Now, what that means is that if I didn't do the multicast thing, the sound would never execute on the clients that are connected. It would execute on the server, it would execute here locally with me because the code still runs there, but it wouldn't execute on these 2 guys, regardless of what condition I put there, even if I didn't have the condition there that says, you know, is locally controlled. Even if I didn't have even if I didn't have this condition there, this wouldn't execute because on movement updated is simply not being executed on those proxies. That's why I have to do the multicast thing and just forcibly execute that piece of code that specifically just plays the sound. Because the way the movement of these proxies is transmitted to me from the server is by just sending location updates, transforms. So location, rotation, and I'm not sure if animation is replicated. It's probably replicated. I think your animation has to rely on specifically settings. I'm not sure how it is actually done, because this is the thing. See, I'm not 100% sure how this works. I'm just fairly certain that it doesn't execute. The code doesn't execute. The simulation doesn't run on these proxies. It is a possibility that the actual state is replicated, like the F saved move is replicated to those proxies from the server. The moves that are generated obviously by some other client. So the state is synchronized, but the execution, but this doesn't run. I'm not necessarily sure how that works. That's somewhat of a fine detail. Because if you had something like an animation state that is reliant on some custom variable that you create. So for example, you have a variable called be dancing. And if you don't explicitly replicate it, like I did with the sound playing through the multicast, if it is just a state variable on the movement component, is that something that the animation blueprint is able to then work with? Is that something that is reflected on these proxies, on these black guys? I don't know. That's actually an unknown for me. So just to take a look on how the blueprint character actually figures in all of this, because you might have noticed that I did not use the C++ version of the character to actually handle the input. So this is just to give an idea how the interaction between C++ and blueprints can work. So blueprints on your blueprint character can be a sort of high-level input handling, and C++ can do the actual work. So what I do here is when the teleport is pressed, I'm going to create an actor that is just this is just a teleport preview. This is a child of actor. It has a particle system and nothing else. Specifically, it is also not replicated. This is not something that anyone else will see but the client. I have no interest in replicating this. So this actor is created. The reference is set. He is deactivated by default. This is not necessary because I did set auto activate to false on this specifically particle system over here. And then a gate is opened so that when the tick control flow comes here via this custom event that I created, so whenever a tick is called, it flows into this cast teleport ray event, cast teleport ray. The flow jumps over here, it enters the gate, and since the gate is now open through this key press, it goes into this function, which is just casting the line trace. I'm going to deproject the middle of the screen onto the world using the resultant position and direction. I'm going to cast for like 5,000. Yeah, 5,000 length. Then if I hit something, I'm going to set the result into a variable here. I'm going to set cancel teleport to false. And if I do not hit anything, then I'm going to set cancel teleport to true. Now, what I do with that is, if cancel teleport is true, then I'm going to disable the fire, the preview particle system. And if cancel teleport is false, then I'm just going to activate it and change the preview actor's location so that it reflects where I'm pointing at and where I want to actually teleport. And the moment I release the key, then I first close the gate so that no more calls are made. And if cancel teleport is not set to true, so there was a connection made and there is a valid location to which I can teleport, I'm going to call set teleport. After which I'm just going to revert cancel turbo to false and destroy the preview actor. That's it. That's the long and short of it. There's funny things that I came across when I was trying to debug the playing of the sound. Specifically, there was a quirk within which the sound doesn't play when the game is out of focus by default. This can be changed by calling this fapp set unfocus volume multiplier to 1. Another quirk is detecting which actual instance plays the sound, because if I open up the mixer, then by default it doesn't have any, it just has a single instance, single application. So what you can do is go into these advanced settings here, uncheck use single process. Let's just keep that to 3. You can change, you can turn on using dedicated server here also. It's something you can do in this menu as well, so that you can actually test out how the code behaves if it's a listen server or a dedicated server. And also for this, I had to limit the frame rate to 30 because the performance couldn't handle it, because by default it is set fairly high and it couldn't handle running 3 clients at once. So when you set these settings like this, you then get, you can play actually the standalone game itself, which I found is more reflective of the final product. Now you should be able to hear the teleport 3 times. Again, you can see the fire is only present on the one client, is not present anywhere else. And the sound played 3 times. Also, if I go away, then the sound is attenuated so that it shouldn't play on those 2 clients. Played on one of them, I think. Now, if I get sufficiently far away, then the sound doesn't play. And that comes down to how the audio is configured. Speaking of which, let's take a quick look at how that works. So you can import a WAV file and you can create a sound cue from it. I do not know anything about audio. I just know that in here you can set attenuation distance so that the sound fades the further away from you are from it when you actually play it in a 3D space somewhere. So that's all of it, I think. Thanks for the request. It was interesting to go over this and hit the problems that I hit. Interesting learning experience. So hopefully this helps. And thanks for watching.